Feliz Navidad! Feliz Navidad! Feliz Navidad! Me gusta tu cortachi!
So now that Thanksgiving is over, please pause the video and read the whole problem before we continue. So we are given. Oh wait, hold up. Whoever made the keyboard, who put the S? Who put the S right next to the A? That could have lowered me great. We are given that the constants are K equals 250 newtons per meter, while Q equals 800 newtons per meter cubed, and we are supposed to use apparently Hooke's law of spring force, where spring force equals negative K times delta S minus Q delta S cubed, and then for part A, we are supposed to be looking for how much work you need to do to compress the spring to 15 centimeters or 0.15 meters. Um, so anyways, we have to use this function where work equals the integral of force times ds. Not sponsored by Nintendo. Although it would be cool if they did sponsor, but they won't. So that's how you find work. We are looking for work. We have to plug in spring force for FSP. So there you go. And then remember to integrate this using the power rule. For integration, you have to remember to use the integral of x to the n dx equals x to the n plus 1 over n plus 1. So the integral of this conglomeration will equal this conglomeration again. So ks squared over 2 plus qs for h to the fourth power over 4, and then we have to plug in 0.15 for this one, and then subtract it for if we applied 0 to it. So it's just gonna be 0.1. It's just gonna be 0.15 for both. There you go. So I plugged in k and q, which is in red here. So after that, you just calculate this, and I got negative 2.9 joules. I actually got negative 2.91375 joules, but to simp for the significant digits rule, I got negative 2.9 joules, and that's my answer for part A. You might get a different answer for part A, so yeah.
Last Christmas, I gave you my heart, but the very next day, you gave it away!
So for part B, we need a percentage, in which the Q delta S cubed has increased the work. So first we have to find the original work, which is just Hooke's law, but minus the Q part. So it's just if our work is just ks squared over 2, and then we can plug in k for, and it's 250 newtons per meter, and then distance will be 0. It would just be 0.15 squared, which is 0.025, and then the answer would be don't forget the negative, by the way, and then the answer would be 2.8 joules, and then after that, to find the percentage, this is what the percentage equation would look like. So since we are looking for percentage of increase, we multiply the work increase by the we multiply 100 by the quantity of the work increase by Q minus the work without Q divided by the work without Q. So that's 2.8, and then if you do the calculations correctly, you'd probably get like a similar answer to 3.9%, and that's what I got for B. So you probably got a different answer, but anyways, this is my answer. So anyways, if you liked the video, please drop a dislike. Please do not drop a like, or you lose your kneecap privileges. Anyway, see y'all in the next one. Oh, so I only have a few seconds left, I see, before I reach the 5-minute mark. Well, anyways.
It's beginning to look a lot like Christmas! Everywhere you are!